Hello everyone. The topic we are going to cover throughout this lesson is the integration. This is the very first lesson of the integration in the HSC Mathematics Extension 2 level. Okay, so we'll have 4 different lessons, but this one is very first lesson, which is a very basic techniques. Some of the questions and skills are related to the Extension 1 level. However, you must have a good understanding so that you can continue to cover the rest of the formal level of Extension 2 questions. Okay, so let's start the first one. The first skills that we're going to learn throughout this lesson is logarithmic function. Okay, it's a logarithmic function. There are 3 formulas are displayed on the board so that you can see them. Is that okay? The first one is quite easy. The stuff that we are going to do, differentiated divided by not differentiated, is log. For example, I'll show you the example. Okay, the best way to learn is looking at the example. Say for example like this one, integrate. Say, what do you see? X squared plus 1 2x dx. Okay, what is the idea? Well, we can rewrite this question like x squared plus 1 and then 2x is obtained when you differentiate the bottom. Okay, say I want to show different color for your attention. Say x squared plus 1 differentiates. Can you see that? When you differentiate x squared plus 1, it will be 2x. So we are okay to write equal sign. Okay, they're the same. Then we are seeing the format as differentiated divided by not differentiated, like this. So we can write the answer clearly, log x squared plus 1. Okay, and then write C at the end as usual. So that's the basic idea. Okay. So we're going to practice a lot of similar things like this, these skills, question 1 to 3 and 4, but nothing is easy. Okay, but nothing is too hard. The other one that you are seeing here, these two are not really worried about in your point. Okay, so it looks very complicated. However, these two formula are written in the standard integral table, okay, as a part of the exam paper. So you are not actually required to remember these two formula, but the only thing that you need to do is to find out which question that you need to apply which formula to. Okay, so that's the important part. The other one that you have to be attend is this part. Okay, it is x squared. Say for example, 1 over square root x squared minus 4 is quite okay. Okay, so it follows the format, so you can integrate by the use of this formula. However, if you have say 2x squared minus 4, you can't, because the formula is specifically writing the coefficient of x squared is just 1. Understand that? It's not 1, so you cannot apply this formula until you remove 2 from the fraction. So that's another thing you have to be careful. Okay, but we'll practice where to use, how to get rid of these 2. Okay, all right then. So that's the very small and brief introduction of the logarithmic functions, how to integrate. Okay, so let's do the questions. Question 1. Okay, integral 2x plus 1 divided by x minus 4. Okay, I'm thinking we can use this formula. Okay, so f dash x divided by fx equals to log fx. Okay, to do it, the order or the power of the numerator must be always 1 less than the denominator. Okay, that is the usual idea. But in this case, the power of the numerator and denominator are the same, so we can't do it. Okay, so we have to make something, okay? We have to make something altered so that it can be applied for this formula, okay? I'll show you how to do it. Your first idea is making 2x minus 8. So why? Because we know the idea, so you say x minus 4. So 2x minus 8 is the idea to cancel x minus 4 and 2x minus 8 and leave it by 2. That's the idea. Do you understand that? Okay, next step is to make a little further, okay? So next step is showing how to separate them. So we're going to separate them, this fraction and this fraction. We just separate them. This one, okay? So 2x minus 8, x minus 4. X minus 4 can be 2x minus 4, x minus 4. Cancel it. So this becomes 2, as you can see over here. Okay? Simple algebra. Next step is to separate them. So 2 becomes one of the integral. 9 over x minus 4 is part of this another integral. Okay? Now, we are almost there. Next step that I did is take 9 outside of the integral so that you can see something over there, okay? So 1, okay? So 1 can be rewritten as well like this one. So x differentiate of x minus 4 will be 1. So that's quite okay. So differentiate divided by not differentiate, okay? So over here, this is what I just did, and then write the answer. So 2x is 2x, 9 log x minus 4 plus c. Does it make sense? Okay, so let's recap of the question again. So your first idea, what was the first idea? To diminish the power of the numerator is 1 less than the denominator. That is the basic idea. How? By looking at x minus 4, we are going to cancel x minus 4 up and down. That was the idea, okay? So we reach the point, then the power of the numerator is 1 less than the power of the denominator, then you can go through. That's how it is. Does that make sense? Good, okay? I'm sure, you guys have a good entering of the topic. And then we're going to practice a little more. Let's do question 2. Question 2. Well, previous one was same power, but this is different story. The numerator has actually one more power than the denominator. It's even harder. So what I'm going to do is not a big problem, okay? Let's take one power at a time, okay? So x squared. Have an idea, x minus 4. What do you want to do? X minus 4, okay? We're going to cancel later on. What do you want to see? If you have x squared minus x, yes, we can cancel something. Does it make sense? So that is the idea how you can approach the question, okay? So this is my idea. X minus 1, okay, it would be great to have x minus 1 above the fraction that we can cancel it. See here, that will be, say, x minus 1, so we can cancel it later on. Understand that? Okay, factorize this, as I've spoken to you right here. Separate them, cancel it, it is x, okay? Now, what you have noticed, the power of the numerator is 2, but it's now 1. So one step makes the power being reduced by 1, okay? So let's do one more time to take this away. How to do? Okay, so x minus 1. We love to have x minus 1 on the numerator, so write it. So I write x minus 1 and plus 1. So this is x, okay? If it has a minus 1, you need a plus 1, okay? Then separate these and these two, like this, okay? So that fraction will be 1. And remaining is 1 over x minus 1. Understand that? Yes, this is good format. 1 can be rewritten like x minus 1 differentiate over here. So differentiate divided by not differentiate, you know what to do. Okay, so that will be x minus 1 log x minus 1, and remaining x becomes x squared divided by 2 is very simple and basic integration. 1 becomes x as well as that, And this is what I just explained to you. Okay, so differentiate divided by, not differentiate, and plus c as normal. Okay then, so we just covered two questions which are having slightly different requirements. Okay, and we have two more questions to go. They will show you even more variety of the skills required. Okay, let's do question 3. Okay, I'll give you just a couple of seconds to think how to start the question. Well, this is power of 3, this is power of 2. Of course, this is one more power than the denominator. So how do you think? Okay, yeah, the clue is this one. We still have to use this formula, okay, for this question. Okay, anyone have a good answer? Okay, let's expand it completely, like this one. Then what to do? Well, in this case, okay, the different question from the previous one. The previous one, we have plus 1 or x minus 2. They're kind of polynomials, okay, multiple terms. But luckily, this is single term. What you want to do, you just separate everything. Okay, so always separate if you can do. That will make the questions nice and easier. Okay, and then okay, x cubed divided by x squared will be certainly x. Okay, x squared cancel will be 3, and so on. What I like to do now, separate again with this separate, with having the separate integral signs like this. Understand that? Okay, the integration of x is easy. Integration of 3 is also easy. It will be like this one. Integration of x will be x squared divided by 2. Integration of 3 will be 3x. Okay. Now, as usual, I prefer, okay, I suggest you guys to take number 3 out. It will make nice and easier so that you don't get much trouble. Okay? Over this one, okay, make the power minus 2. This one, you can see that is x dash. So x, derivative of x will be 1. So we can write the format differentiate divided by, not differentiate. Okay? And this one, you can see plus 1, just a basic integration. Minus 2 plus 1, x minus 2 plus 1. Understand that? So that is minus 1. 1 divided by minus 1 is minus. Minus 2 plus 1, which is x minus 1. You can write 1 over x. So this will be integrated like this. So everything is sorted out now. So as I said to you, right over there, that equals to 3 log x minus 1 over x and plus c. So easy. Okay? So different question will require slightly different skills per questions. Okay? Okay, question 4. This question is regarding to the log formula. Okay, this is different from differentiate divided by, not differentiate. This question is related to the second and the third formula that I showed you at the very first lesson. Okay, oh, sorry, very first slide of this lesson. Okay, now we got to remind. Okay, I'll give you some attention. When you use the formula, okay, there is a prerequisite. So what's the prerequisite? Okay, is if you do x squared minus a squared. Okay, so that must be 1. The coefficient of x squared must be 1. So this must be 1. Now question is not 1. So we cannot use the formula until you get rid of this 9. Okay, so that's the point. So I'm going to show you how to get rid of 9 so that we can apply this formula in integrating this question. Okay, so let's do. Your first step from the left hand side is this one. We're going to factorize by 9. Okay, see what happens. If you factorize this divided by 9, it becomes x squared minus 4. Okay, what do I see? Finally, we have 1 just in front of x squared. Okay, it's a good sign. Okay, now next step is to remove this 9. So square root of 9 becomes 3. Okay, so we are successfully taking 3 out of the square root. but this 3 is still inside of the integral, so we always prefer or always safer to take this number outside of the integral like this. Okay, now 1 over 3 is just 1 over 3. We don't really take care about this 1 over 3 because we can do this one and then multiply 1 over 3 by later on. It's not a problem at all. Okay, so now at this time, have a look at your standard integral table. So how you can integrate simply following the integral formula. Did everyone write the answer in your booklet? Okay, I'll show you the answer. Okay, so that will be the answer. Okay, that's the answer of integrating here. Okay, plus c at the end, of course. Now, what you are seeing here, okay, we have x squared plus blah blah blah, but it is quite different from this one. So it tells us we have to do something else to make them looking the same. Okay, what we are seeing here, that equals to 4, 16, while this is 1 and 4. So this is 4 times for this one. So this is 4 times for this one. We're going to multiply by 4. The fact that we need to multiply by 4 inside of the square root, it is same as multiply by 2 for the square root. If we multiply by 2, we have to divide it by 2. Okay, so we're not going to make the value changes, but we are only making changes to the format. Does it make sense? Over here, so eventually what we have to do, we need to multiply by 2 and 2 upside and down like this one. So multiply by 2 will be this, and then divided by 2 is nothing happens. Okay. Next step is to make a single fraction over here. Okay, so x becomes 2x, and 2 is the whole common denominator. Now what you are seeing, everything the same. Okay, so this part is the very same as this part. Okay, so as long as we can get rid of these two, that's at the end of the story. Okay, so let's try to get this rid of. What you can see here, okay, in get rid of the bottom 2, what you may want to do is to utilize the properties of the logarithm. So what are they? So can you remember that? So in terms of the log a times b, what do you want to do? A times b, yes, it is log a plus log b. Okay, you probably learned this one at least 6 months ago or a year ago. Okay, what else? Log a divided by b. What do you think? Well, if it is multiply, it will be plus. So if it is divide, so what do you see? A is minus. Okay, so you have to make sure you know how to do this. Okay, this log is following the format. Okay, so log a divided by log b. So this is a, this is b. Then we can write log a. So this can be rewritten here. I'm doing better. ln, so 2x plus 4x squared minus 16 minus log 2. Do you see this? I just use this formula, this property, and then a third. So multiply a third and simplifying or expanding by the common factor. Okay, so you can see like this one. Does it make sense? Okay, we are almost there. So what do you think about this one? So that's the particular number, say 1.2345, whatever. It's just a fixed number while they are pronumerals. Okay, so that c is also a number, a kind of fixed number or constant number. So we don't really need to leave them as specifically like this. So if you calculate this is also a constant. So constant plus constant. So this whole thing is constant. So we can write just c. We don't really need to know what c is, but we just reserve a room for the constant. Okay, it looks funny. That plus that is c. It doesn't work as a kind of basic arithmetic, but you need to understand the c is kind of reserving a room for the number. Okay, so we are not really required to find out what the number is, but we just find the number. Okay, so reserve a room. Okay, so constant plus constant is constant, whatever that is. So that is the point of the question. Okay, so of the recap of this topic. Okay, so basically question 4 is not highly popular questions, but it is coming. Okay, so it is in the exam questions and so on, but most of the question you have to be careful in getting rid of the leading coefficient. Okay, so make sure you must be able to make it number 1. Okay, remaining thing is just algebra plus basic properties of the log. Okay, so that's the point. Okay, we'll see you guys in the next lesson.